All right, hello, Matt 10, Mr. Beeland here with your lesson for today. We're still talking about systems of linear equations, and we're talking about solving them algebraically, and we're still talking about looking at them by solving through elimination, okay? So remember, with elimination, we were just taking one of our equations and then subtracting or adding it by another one to try and cancel out some of the variables. Now, the ones that we were previously doing, we would have something like x minus x or 3x minus 3x. And they were all really nice and lined up like that. But what happens if there are no common coefficients? See, I've got an x and 2x and 3y and 7y, and there's just no obvious way to cancel those out. What do we do? So what we do is we multiply one or both equations by some number. You'll have to determine that. And what you multiply it will create matching. I'm going to also say matching or opposite coefficients. Okay, so this basically just means that we have another step, right? We had step 1, step 2, step 3, step 4 before. Now we've got step 0, right? We've got to make sure the coefficients are the same. Okay, so let's look at this one here, for example, okay? So x plus 3y equals 6. 2x minus 7 equals negative 1. Nothing's equal. The most obvious one here is to try and make the x's the same, right? So how could we do that? Well, I can double 1. 1 times 2 is 2. So I can double this whole thing. Whatever I do to the left, I got to do to the right. So I got to times the whole thing by 2. So I'm just going to do a little arrow here. I got to rewrite everything on this side here, doubling everything. So 2x plus 6y equals 12. And we still have 2x minus 7y equaling negative 1. I don't have to change anything there. Now, we go back to our steps from before, and we subtract one from the other to cancel stuff out. So I end up with a 0 there, and then 6 plus 7 is 13y, and then 12 minus negative 1, so we get this is equaling to 13, so y equals 1, and I'll put that down in the corner here. And then I take that 1, I plug it back in up here, and we get x plus 3 equals 6, so x equals 3. All right, let's do a couple more examples here just to make sure we got it down. So let's look at this one here. 9x plus 3y equals 12. 2x plus y equals 5. Now, you're going to want to multiply to try and make one of these line up. If you only have to do one multiplication, that's fine. Sometimes you might have to multiply both, but if you can avoid it, I would recommend it. So in this case, I'm not going to try and make the x's the same because the only way I can do that is by making these numbers 18, and that would be 2 steps, and that is 1 step too many for me. Instead, I'm going to just make it so that the y's are equal, and to do that, I just need to multiply this one by 3. So let's rewrite this. The top one is the same. Nothing's changed there. And then with the bottom one, I am tripling all these. So 2 times 3 is 6 plus 3y equals 15. Okay, and then I'm just going to take this one and subtract it. What do I get? 9 minus 6 is 3. That will cancel out. And then 12 minus 15 is negative 3. So then divide both sides by 3, and you get x equals negative 1. Great. And then we just plug that back up here. So 9 times negative 1 plus 3y equals 12. So we've got negative 9 here now. Add that to that side, you get 3y equaling 21. Divide by 3, y equals 7. Okay. One more example here. You know what? Let's try and find one here where it's not obvious what we have, okay? Let's see here. Which one looks good? This one right here. Let's look at number 8. Okay? So in this case, there's no number. I can't just double or triple this to make this, right? It's just not going to work. So what I'm going to do is, at this point, I can just pick whichever one I want to get rid of, x or y. So in this case, let's try to get rid of the x's. Let's make those equal. So in order to make 3 and 5 end up with an equal or opposite number, I'm going to multiply this one by 5 and this one by 3. That's the easiest way to do it, but sometimes you can pick a lower number, right? In case you have a lower common multiple, but in this case we don't. So we'll rewrite this. We've got 15x plus 15y equaling 45. And then we've got 15x plus 12y equaling 30. And then again, I'm just going to subtract 1 from the other. So that's going to cancel out there. I'll draw my line there. So that cancels out. 15 minus 12 is 3y. And then 45 minus 30 is 15. So then y equaling 5. Great. Then we take that 5, we plug it back into our top equation. 3x plus 3 times 5 equaling 9. So 3x plus 15 equals 9. 3x equaling negative 6. So x equals negative 2. There we go. Okay, so again, you're going to try and multiply one of them into making the same coefficient as the other. Sometimes you might need to multiply both, like in this example. But again, if you can avoid it, if you can just do it with one, like for example, number 7, you can just double this one to make the y the same, then I'd recommend doing that, right? No need to do extra steps. Okay, that's it for this section, okay? So we've covered how to solve systems of linear equations using graphing and algebra, 2 methods in algebra, one being the substitution and the elimination. The great thing about these is that they're all just a whole bunch of tools in your toolkit, and it's up to you to decide which one to use in a situation, whichever one seems more comfortable or easier to you. Okay, that's it. Take care, everybody.